Welcome to the Deep Dive. Today, we're going to be exploring this really interesting thing. It's called three-dimensional science.
Ooh, three-dimensional science.
Yeah, and no, it's not about those funky glasses you wear at the movies or anything like that.
Okay.
It's really more about a framework for learning and teaching science.
Oh, interesting.
Yeah, and one that emphasizes interconnectedness.
Okay.
Like how it all kind of fits together.
That makes sense.
Yeah. So get ready to ditch those old dusty textbooks because we're going beyond just memorizing facts today.
Yeah, it is a very fascinating shift, in how we approach science education.
Mm-hmm.
We're really moving away from just memorizing isolated facts.
Right.
And more towards building like a deeper understanding of how science truly works.
I love that. So let's break down these dimensions.
Okay.
Like I'm picturing something like a delicious layer cake right now.
All right.
What are the key ingredients here?
Okay, well, imagine this cake has 3 layers.
Okay.
The first layer is all about science and engineering practices.
Or shortened to SEP.
SEP. Got it.
These are the actions that scientists and engineers take when they're exploring the world around us.
Okay.
It's like the recipe steps for doing science.
So it's not just about like knowing all the facts.
Right.
But knowing how to do science.
Exactly.
Okay.
It's about asking questions,
Mhm.
designing experiments, analyzing data, and then using that information to kind of build and refine our understanding of things.
That makes a lot of sense. I remember feeling lost in like science class,
Yeah.
back in the day because we would just kind of jump from topic to topic
Yeah.
without really grasping like the underlying process of how scientists actually like figured things out.
Yeah, and that's unfortunately a common experience,
Yeah.
but the SEP layer that we're talking about
Okay.
really helps provide that missing context.
Okay.
Take asking questions, for instance.
Yeah.
It seems simple, right?
Yeah.
But there's a real art to framing a scientific question effectively.
So it's not just about like having a question.
It's about asking the right questions.
Precisely. A well-crafted scientific question really sets the stage for an entire investigation. It needs to be testable, specific, and focused on a particular phenomenon.
Oh.
For example, instead of asking like, why is the sky blue?
Right.
A more scientific approach might be, how do different wavelengths of light scatter in the atmosphere?
Okay, I see the difference there.
Yeah,
Yeah, the second question really leads you down like a path of investigation.
exactly.
But the first one is just kind of like
It's too broad.
too broad, yeah.
And as you go deeper into these practices, you start to see how interconnected they all are.
Okay.
Asking the right questions leads to developing and using models,
Mm-hmm.
which then informs how you plan and carry out investigations.
It's all connected.
Yeah.
Okay, so that's our first layer.
Yes.
The doing of science.
Yes.
What about the next layer of this cake?
Okay, so the next layer is all about the cross-cutting concepts.
Cross-cutting concepts.
Think of these as the big ideas that connect different areas of science,
Okay.
like threads weaving through the entire tapestry of scientific knowledge.
So this is where we start to see those connections between
Yes,
like physics and chemistry and biology.
exactly.
Okay.
One of those cross-cutting concepts is patterns.
Patterns.
Scientists are always on the lookout for patterns
Right,
in
yeah.
data, in nature, everywhere.
Yeah.
Recognizing patterns helps us make predictions, identify trends, and understand relationships.
And I never really thought about it that way, but it's true.
Yeah,
Whether it's the arrangement of planets in our solar system
right.
or the repeating structure of a DNA molecule, like patterns are everywhere.
They are, and they're not just pretty to look at.
Right.
Patterns often point to underlying principles or laws that govern the natural world.
Mm-hmm.
For example, noticing the pattern of seasons changing
Yeah.
led to the understanding of Earth's tilt and its orbit around the sun.
That's a great point. So patterns are one thread connecting all these different areas of science.
Yes.
What other threads are kind of woven into this tapestry?
Another crucial one is cause and effect.
Cause and effect.
It's a fundamental concept that helps us understand how things work, how events are related, and how changes occur.
Okay, that one seems pretty intuitive, right? Like
Yeah,
every action has a reaction.
Right. But in science, it goes beyond just simple reactions.
Okay.
It's about tracing complex chains of cause and effect, understanding feedback loops,
Okay.
and recognizing that sometimes a single effect can have multiple causes.
So it's not always just like a straightforward
Yeah.
A to B relationship.
Not always. Think about something like climate change.
Okay.
There are multiple contributing factors,
Right.
complex interactions, and long-term consequences to consider.
Yeah.
Untangling those webs of cause and effect is a major challenge for scientists.
I can see how that would be incredibly complex.
Yeah.
Okay, so we've got patterns.
Yes.
We've got cause and effect.
Yeah.
What other cross-cutting concepts should we be aware of?
Another fascinating one is scale, proportion, and quantity. This concept helps us understand the vastness and intricacy of the universe
Okay.
by recognizing that we can study phenomena at different levels,
Oh,
from
interesting.
the incredibly small to the unimaginably large.
So we can zoom in and out,
Yes.
like using a microscope or a telescope to get different perspective.
Exactly. Imagine studying a tree.
Okay.
You could look at the entire forest ecosystem,
Right.
or zoom in to study the community of organisms living on a single branch,
Whoa.
or even go down to the cellular level of a leaf.
Yeah.
Each level offers a different perspective and a deeper understanding of that tree.
It's amazing how much we take for granted,
Oh.
just by observing things at our usual human scale.
Right.
I'm starting to realize that there are, like, entire worlds existing at scales that we barely even notice.
And the fascinating thing is,
Yep.
the principles of science often apply across these different scales.
Right.
The laws of physics governing the motion of planets
Uh-huh.
also apply to the movement of atoms.
Wow. Okay, so this scale concept is all about recognizing that the universe operates at multiple levels,
Yes.
and that studying those different levels can reveal a lot about how things work.
Precisely. And it also helps us appreciate the interconnectedness of things.
Okay.
For example, understanding the scale of the atom helps us understand the properties of materials,
Right.
which in turn impacts how we design and build everything,
Yeah.
from bridges to smartphones.
Wow, it's like a chain reaction of knowledge.
It is.
Okay, so we've covered patterns, cause and effect, and scale.
Yes.
What other big ideas connect different fields of science?
Well, there's the concept of systems and system models.
Okay.
This one is all about recognizing that the world is made up of interconnected parts that work together to create a larger whole.
So everything is connected,
In a way, yeah.
from the smallest atom to the largest galaxy.
And understanding how systems work is essential for tackling complex challenges,
Right.
like climate change, designing sustainable cities,
Yeah.
or even just understanding how our own bodies function.
Okay, I'm starting to see how these cross-cutting concepts
Yeah.
aren't just like these abstract ideas. They're
Yeah.
actually tools for understanding and solving real-world problems.
Exactly. And what's really interesting is that these concepts aren't just limited to science.
Mm.
You can apply them to any field, right? From business to art to history.
Okay.
It's a way of thinking that helps you make connections and see the bigger picture.
So we've got our first two layers of the cake,
Okay.
the science engineering practices
Yes.
and the cross-cutting concepts.
Huh?
I'm guessing the final layer is where we get into the actual, like, content of science?
Yeah. Got it. The final layer is all about the disciplinary core ideas,
Okay.
which are the fundamental concepts and principles in different scientific disciplines.
So if the practices are the how of science,
Yes.
and the cross-cutting concepts are the connectors,
Mm-hmm.
then the disciplinary core ideas are the actual what of science.
That's a great way to put it. This layer includes things like the laws of motion in physics,
Right.
the periodic table in chemistry, and the theory of evolution in biology.
Okay.
It's the foundational knowledge that scientists build upon as they explore the world.
So it's like each discipline has its own set of building blocks
Yes.
that kind of fit together to create like a larger understanding of that field.
Exactly. But what's really important to remember is that these three layers, the practices, the cross-cutting concepts, and the disciplinary core ideas,
Yeah.
they're not separate entities.
Right.
They're intertwined and interdependent,
Okay.
creating a very dynamic and engaging approach to learning and teaching science.
This is already making me rethink how I view science.
Yeah.
It's not just about memorizing facts anymore.
Right.
It's about using these tools and concepts to like explore, question, and connect the dots.
That's the beauty of three-dimensional science.
Yeah.
It's a shift from passive learning to active engagement, from isolated facts to interconnected understanding.
This has been a great start to our deep dive into three-dimensional science.
Yes.
We've laid the foundation, with these three key layers.
And there's so much more to explore.
Yeah.
I'm looking forward to diving deeper into like the specific practices, concepts, and how they all work together to create this more holistic view of science.
Me too. So stick around as we unpack those layers even further and discover how this approach to science can not only change how we learn, but also how we see the world.
Welcome back. I'm excited to delve deeper into those cross-cutting concepts.
Okay.
They're the real game changers, when it comes to understanding that interconnected nature of science.
Yeah, I'm ready to connect some dots.
Yeah.
We left off talking about systems and system models.
Right.
What makes this concept so crucial for understanding science?
Well, it helps us shift from looking at individual parts
Okay.
to understanding how those parts interact within a larger whole. Think
Okay.
about the human body.
Okay.
It's a complex system with organs, tissue, cells,
Right.
all working together. You can't fully understand how the heart works without considering its role within the circulatory system, right?
Right. It's all about context.
Yes.
And it makes me think about how this applies to bigger issues like climate change.
Exactly.
You can't just look at carbon emissions in isolation.
Right.
We have to understand how they interact with the atmosphere, oceans, and ecosystems.
Exactly. And that's where system models come in.
Okay.
They allow us to visualize those complex interactions,
Okay.
test different scenarios, and predict how a system might respond to change.
It's like having a map of a complex machine,
Yes,
helping you understand how all the gears and levers fit together.
precisely.
So systems are all about connections and interactions.
Yes.
What other cross-cutting concepts kind of reveal these hidden relationships in science?
Let's talk about energy and matter.
Energy and matter.
This concept highlights that everything in the universe is made up of matter.
Okay.
And matter is anything that has mass and takes up space.
Okay.
Energy, on the other hand, is the ability to do work or cause change.
So my chair, my coffee mug, even me,
Right.
we're all made up of matter.
Yes.
And the electricity powering my lights and the heat from my stove are forms of energy.
Precisely. And one of the fundamental laws of the universe is that energy and matter can't be created or destroyed,
Okay.
only transformed from one form to another.
Oh, wow.
Think about burning a log in a fireplace.
Okay, the wood turns to ash, releases smoke,
Yes.
produces heat and light,
Uh-huh.
but it doesn't just disappear.
Right. The matter in the wood transforms into different substances,
Okay.
and the stored chemical energy transforms into heat and light energy.
Okay.
But the total amount of energy and matter in that system remains the same.
Wow, that's pretty mind-blowing when you think about it.
It is.
It means that, like, the atoms making up our bodies might have once been part of a star.
Right.
Or a dinosaur.
It's true. And understanding these transformations of energy and matter is essential for so many things, from developing new technologies to addressing environmental challenges.
Okay, so we've got systems.
Yes.
We've got energy and matter. What's the next big idea that connects the scientific dots?
Let's explore structure and function.
Structure and function.
This concept highlights the beautiful relationship between the form of something and what it does.
Okay.
The structure of an object or organism is often intimately linked to its function.
So, like, the shape of a bird's wing is perfectly designed for flight.
Exactly. The structure of the bones, feathers, and muscles all work together to allow for lift and maneuverability.
Right.
But it's not just about external shapes.
Yep.
Think about a plant cell.
Okay.
Its internal structure, with chloroplast for photosynthesis and a cell wall for support,
Yeah.
directly relates to its function of producing energy and maintaining its shape.
So the form dictates the function.
Yes.
It's like a key fitting into a lock.
Yes.
The specific shape of the key determines which lock it can open.
That's a great analogy. And this principle applies across different scales,
Okay.
from the intricate workings of a cell to the engineering marvels of bridges and buildings.
It's making me think about how scientists are always trying to figure out the structure of molecules to understand how they function,
Absolutely.
like in drug development or material science.
Knowing the structure of a molecule can help predict how it will interact with other molecules,
Right.
leading to breakthroughs in medicine, agriculture, and countless other fields.
This is so fascinating.
It is.
Each of these cross-cutting concepts is like a new lens
Yes,
through which to view science.
it is.
What's our final stop on this conceptual tour?
Let's end with stability and change.
Stability and change.
It might seem like these ideas are opposites,
Yeah.
but they're actually two sides of the same coin.
Right.
Understanding the interplay between stability and change is crucial for understanding how the world works.
So some things stay the same,
Right?
and some things change.
Yes.
How is that a big idea in science?
Yes. It's about recognizing that even systems that appear stable
Okay.
are constantly changing, often in very subtle ways.
Okay.
Think about a forest ecosystem.
Okay.
It might seem relatively stable over time, but there are always fluctuations in populations, weather patterns, and resource availability.
Right. It's a delicate balance.
Yes.
And if one element changes significantly,
Right.
it can throw the whole system out of whack.
Exactly.
Yeah.
Understanding those thresholds of change,
Okay.
what factors contribute to stability, and how systems respond to disruptions is essential for everything.
Yeah.
From managing ecosystems to predicting earthquakes.
So stability and change are like two dance partners,
Yes.
always interacting and influencing each other.
Beautiful.
And understanding their choreography is key to understanding the world.
That's a beautiful way to put it. And this concept is incredibly relevant to our lives today.
Okay.
We're facing unprecedented rates of change in climate technology and global systems.
Yeah.
Understanding how stability and change interact can help us navigate these complex challenges and find solutions for a more sustainable future.
Okay, so we've explored some pretty big ideas here.
Yes.
Systems, energy, and matter, structure and function, and stability and change.
Yes.
It's like we've zoomed out from the details of science
Yes.
to get like this panoramic view of the underlying principles that connect everything.
Exactly. And remember, these cross-cutting concepts aren't just abstract ideas.
Right.
They're tools for thinking, for making connections.
Yeah.
And for understanding the world around us in a deeper, more meaningful way.
I'm starting to see how these concepts can help us make sense of complex issues,
Right.
ask better questions, and find solutions to challenges we face,
Yes.
both individually and as a society.
That's the power of three-dimensional science. It's not just about learning facts.
Right.
It's about developing a way of thinking that can empower us to be more informed citizens, more innovative problem solvers, and more curious explorers of the world around us.
This has been an incredible journey so far.
It has.
We've explored the doing of science with the science and engineering practices. We've connected the dots with the cross-cutting concepts.
Yes.
And I'm eager to see how that final layer,
Yes.
the disciplinary core ideas,
Right.
fits into this framework.
Me too.
Yeah.
Let's dive into that next layer and see how these foundational concepts come to life
Okay.
when we apply the practices and view them through the lens of the cross-cutting concepts.
Welcome back to the deep dive.
Yeah.
I feel like we've been on quite a journey, exploring these dimensions of science.
It has been quite a journey.
Yeah. And now we're reaching like the final layer of our cake,
Okay.
the disciplinary core ideas.
Yes. This is where we get into the nitty-gritty of specific scientific disciplines,
Okay.
like physics, chemistry, biology, and earth science.
Okay.
These core ideas are like the fundamental building blocks of knowledge in each field.
So if the practices are like the how,
Right.
and the cross-cutting concepts are like the connectors, the disciplinary core ideas are the actual content of science,
That's a good way to think about it.
like the facts and theories we learn about in textbooks.
But it's more than just memorizing facts. It's
Uh-huh.
about understanding the key concepts, principles, and theories
Right.
that explain how the world works,
Yeah.
from the motion of planets to the behavior of atoms.
So what are some examples of these core ideas?
Well, in physics, you have concepts like Newton's laws of motion,
Okay.
the laws of thermodynamics, and the nature of light and electromagnetism.
Okay.
These ideas explain how objects move, how energy is transferred, and how the universe behaves at like a fundamental level.
In chemistry, it's things like the periodic table,
Yes.
chemical bonding, and the structure of matter.
Exactly.
These concepts help us understand the composition of substances, how they react with each other,
Right.
and how new materials are created.
And in biology, you have core ideas like cell theory,
Oh, cool.
genetics, and evolution.
Okay.
These concepts explain like the building blocks of life, how traits are passed down through generations, and how life on Earth has changed over millions of years.
It's like each discipline has its own set of tools,
Right.
its own language, and its own way of approaching the world.
Yes.
But these cross-cutting concepts that we've been talking about,
Right.
patterns, cause and effect scale, and so on,
Uh-huh.
they help us see the connections between them, right?
Absolutely. The cross-cutting concepts act as a bridge between these different disciplines.
Okay.
They provide a framework for understanding how the core ideas in one field relate to the core ideas in another.
So it's not just about learning science in silos.
Yeah.
It's about seeing the bigger picture,
Yes.
the interconnectedness of all these different areas of knowledge.
Precisely. And that's where the science and engineering practices come in.
Okay.
These practices like asking questions, developing models, and analyzing data,
Uh-huh.
those are the tools we use to explore these core ideas regardless of the specific discipline.
Okay, so we've got the what of science, the core ideas.
Yes.
We've got the connectors, the cross-cutting concepts.
Yeah.
And we've got the science and engineering practices.
Yes.
It's starting to click.
And when all these layers work together,
Yeah.
that's when the real magic of three-dimensional science happens.
Okay.
It's not just about learning facts in isolation. It's about building a deeper understanding of how science works, how knowledge is constructed, and how we can use that knowledge to understand and solve problems in the world around us.
I'm starting to see science in a whole new light.
Mm-hmm.
It's not just about memorizing the periodic table or the names of dinosaurs.
Right.
It's about using these tools and concepts to explore, to question, to make connections, and to see the world with new eyes.
That's the beauty of three-dimensional science. It's a shift from passive learning to active engagement,
Yeah.
from isolated facts to interconnected understanding. It's about empowering people to think like scientists, to ask questions, to seek evidence, and to never stop exploring the wonders of the universe.
This deep dive has been truly enlightening. Thank you so much for sharing your insights and expertise.
It's been a pleasure exploring these concepts with you and our listeners.
And to all our listeners, we hope this journey into the world of three-dimensional science has sparked your curiosity and given you a new perspective on the power of scientific thinking. Keep exploring, keep questioning, and keep those minds engaged.